Hey everybody, my name is Tom Tullis. This is the Tomb of 3D Printed Horrors, and today we're going to take a look at the Ender-3 V2 Neo. Now, the Neo series of printers are simply upgrades of existing Ender printers. There's an Ender-3 Neo, an Ender-3 Max Neo, and in this case it's an Ender-3 V2 Neo. Now, if you've been following along with this channel, you know my absolute favorite printer for our office at Fat Dragon and stuff is the Ender-3 V2. And if you watch that assembly video, there's a number of upgrades I recommend doing. Better bed springs, all metal extruder, things like that. The Neo takes a lot of those upgrades that people usually do to their V2s and make them standard on the Ender-3 V2 Neo. Now, another thing they've added in is a CR Touch automatic bed leveling system on this, which is really nice too. It also has a flex steel spring plate to print on, so you can just take it off, you flex it, and your prints pop right off. And that's really nice too. So for the price, you're getting it's a little bit more than an Ender-3 V2, but when you factor in the cost of the upgrades, if you were going to do them yourself, and the time, you're money ahead to just go ahead and buy the Neo version of the Ender-3 V2. Now, the other advantage the Neo has over the standard V2 is it comes largely assembled at the factory. If you've never assembled a 3D printer before, an Ender-3 V2 will take you anywhere from an hour and a half to 2 hours probably. The Ender-3 V2 Neo is going to take you about 10 to maybe 15 minutes max, and there's not much to it. What you're seeing here on screen is it. You're going to attach the upright gantry to the base with 4 bolts. Then the spool rack attaches on top with 2 T-nuts, and the LCD screen on the right-hand side attaches with 3 T-nuts, and that's it. Again, this is very, very simple. Plug a few things in on the back and you're done. 10-15 minutes tops. I really like this printer. This, as I said, it comes with all of the upgrades I would recommend except for one, which we'll get into later. It's the coupler that holds the bowden tube into the hot end. I'm not wild about the design they have on this. The replacement one I like is only 50 cents. It's easy to put on, so it's not like it's going to, break your wallet. Upgrading this to what I think needs to be done on it for better operation. So let's dive in here. The first thing you're going to want to do before you start any assembly is make sure your base is square on this. I have not had any of my Enders come out of square. I think maybe I had to adjust my very first Ender 5 years ago, but none of them since have come out of square. What you want to do is set the base on a totally flat surface. Make sure it doesn't wobble, i.e. have one corner higher than the others where you can rock it back and forth. If by chance you would, what you're going to do is these 4 screws on the left side and the right side, you loosen them a few turns, and then push the base down into level to where all 4 corners are on the flat surface, and then tighten all 8 screws again. Now it will be in level and it's not going to wobble on you. But just it's a good thing to check. It's easier to do now than later on once you got everything assembled. So just take a minute, check it out, and if it does need it, loosen those 8 screws and tighten them back up. So we're going to get started here. If you have them, grab 2 filament boxes. This is the perfect height for helping you work on this base. We're going to check out a few things here before we get started. The first thing is we're going to make sure the wiring is all attached properly on the inside. So this small screw here, go ahead and take that out. It locks the bottom cover plate for the electronics compartment. Go ahead and take that off. And then what you're going to do is you're going to flip this over and let the sides rest on those spool boxes so that it's not putting any pressure on the build plate. And then you're going to take out those remaining 3 screws, and keep in mind the long screw goes into the oval hole at the top. And when you pull the cover off, don't yank it. It is attached with a fan, okay? And what you're looking for, there's going to be 3 red wires and a series of red and black wires. 2 of them there's going to be 4 red and 2 blacks. They're the wires that are going into those green housings at the top and upper left. And you're just going to take the screwdriver that came with the printer and tighten all those up. You want to make sure those wires are nice and tight. And once you're done, you're just going to put that cover plate back on and put the 3 screws back in. The short screws go at the front bottom, and the long screw goes at the top back into the elongated opening. And you can turn it back over, put that last screw in. Sometimes I just leave that one out because it really doesn't do much, but you can put that back in. The next thing we're going to do before we start assembly is check our eccentric nuts. The eccentric nuts are simply a way to adjust the tightness of the wheels for the portions of the printer that move. The wheels run into the V-groove tracks on the Y-axis, the X-axis, and if they're too tight, you can get flat spots on them. As those flat spots develop, your print quality will decrease and you'll have to replace the wheels, and that's a real pain in the butt. You don't want to have to do that. My original Ender-3 I got 5 years ago still has the original wheels. They're in pristine condition because I have adjusted them in the way I'm going to show you here. And this is very important. I know if you're just getting into 3D printing, you want to get this printer together and get your first print going in the first 20 minutes that you've got the printer out of the box. Trust me when I say this. Take an extra, half hour here. Do the things I'm telling you to do, because they will save you a lot of headache down the road. If you, like these eccentric nuts, if you take your time and get these dialed in now, these things are still going to be working great for you 3, 4, 5 years from now. You're not going to have to replace them. You're not going to have to go through the aggravation of tearing this machine back apart again. So take your time and do it right now. So eccentric nuts are easy to identify from the other nuts on the other wheels because they are hexagons in cross section, as you're seeing here. An eccentric nut simply has the center hole offset in the middle of it. And what that does is when you have a screw going through that hole and you rotate the nut, that screw will make an orbit. So as you see here, this screw is offset to the side. And what happens is the eccentric nut is shown here in yellow. As you turn it, as you rotate that nut, the wheel with the screw going through at an offset is actually rotated away from the V groove on the aluminum extrusion. And this is how you loosen and tighten wheels with an eccentric nut, okay? So when you get into this printer, you're going to want to check all of the wheels. And what you want to be able to do is grab any of these wheels with 2 fingers, your thumb and your forefinger, and with force, be able to turn it without whatever it's attached to moving. So I should be able to turn this with 2 fingers, these wheels, and that carriage will not move along the rail. If I can do that, it means these eccentric nuts are correctly set and my wheels will not wear prematurely. So I'm going to check them in all of the positions. And in this case, this one is way too tight. I'm just going to get the wrench that comes with the printer. And whether you'll have to turn this clockwise or counterclockwise is different for every position because it just depends which way they turned it to tighten it at the factory. But you're just going to want to play with it. Turn it just a little bit. You're not going to turn it like a full half turn. That's not possible with these. It's just going to be a few degrees one way or the other, and you're just going to have to play to figure out which way it's going to go to loosen. But loosen it up. You don't want it too loose. You just want it to where with 2 fingers you can turn it with force without moving the carriage. And you're going to do that on each one of these. There is an eccentric nut here. This is looking from the rear of the printer, but it will be on the end of the X-axis extrusion that has the tension adjustment for the belt at the far end. There are 3 wheels there. It's the wheel that's off on its own on a single side is the one with the eccentric nut. The next one you're going to want to check is the eccentric nut on the movable hot end assembly. Again, it's the wheel that's off on its own on the bottom side. The eccentric nut goes between the wheel and the carriage. The nuts you're seeing here in this image that attach the screw are not the eccentric nuts. They're just the nuts that are attaching the screws. The eccentric nut is on the opposite side of the wheel. I just can't get in there to get a good photo, but you'll be able to find it. On the opposite side of the x-axis, where you have the extrusion feed motor, is a single, again, it's the single wheel on the opposite side of the two wheels, and there's your eccentric nut for that. And then finally, underneath the print bed, if you're looking from the front towards the back, there are two eccentric nuts. Both of them are going to be to your right-hand side viewing it. There's one up front, there's one in the back. Both will need to be adjusted. So once you have those to where you like them, and sometimes, just depending on the way these things are milled and drilled and everything at the factory, you can't get it too loose. And you may have one that you just can't loosen with two fingers. If that's the case, it is what it is, and just move on. But if you can adjust it to where you can just barely move them with force, with your thumb and forefinger, do it. You'll be grateful for it. These things will last much, much longer. Okay, next step is you're going to assemble and attach the upright vertical gantry to the base. You're going to need the 4 long black bolts that come with the printer, 2 on each side. The easiest way to do this is, if you can, get somebody to help you and hold the stuff in place. Otherwise, you can do it. It's just going to be a little awkward. But use the big, thick piece of foam that came with the printer to set the parts on. That way, nothing's getting damaged on your hard table. But you flip it on its side. You put the 4 bolts in. Tighten them down, but don't put all of your weight into it. Remember, these are steel bolts going into an aluminum threaded hole. It is possible to strip those aluminum threads out. So once you get it tight, don't just put all your muscle into it, put your weight into it. You don't want to do that. Just get them tight and you'll be okay. Next up is going to be attaching the LCD screen and the spool holder rack. Both of these attach with T-nuts. Now, T-nuts are kind of odd. You don't want them at weird angles like I'm showing you here. You want both of them parallel, going in the same direction as the slot you're going to fit them in. You're also going to unscrew them to where they're almost, not quite coming off, but almost. So you have a good gap here if you push them up like I'm showing here. And that way they fit down into the V slot perfectly before you tighten them up. So go ahead and put that spool holder on the top. The holder points to the rear of the machine, and tighten those up with the included hex wrench. One thing I really like to do with these spool holders is, I know people like buying the real expensive aftermarket ones. They're about 25 bucks on Amazon, and they have the ball bearings in them to make them spin freely. You can get pretty much the same effect by just taking PTFE plumbing tape that you can get at any hardware store. This is what you wrap the threads on plumbing pipes with. You can probably get a roll of this for like 50, 60 cents. And just wrap it on here. Remember, wrap it in the direction the spool is going to unwind. And that way the spool isn't unwinding the tape every time it's turning. It's going to actually be tightening it. And wind that on, and when you're done, just take a piece of Scotch tape and tape it on the bottom of the spool holder, not the top, where the spool is going to touch and it would cause friction. Do it on the bottom where there's a gap. And this PTFE tape is really slick, and it's going to reduce the friction quite a bit for that spool as it unrolls. And it just helps eliminate any under extrusion issues from friction, and makes your prints look just a little bit better. And it's a real easy fix to do. So next up, we're going to attach the LCD screen. These are also T-nuts, and you're going to line them up parallel with the V-grooves, just like you did for the spool holder. Get those tightened up. Now, next up, you're going to want to attach the LCD cable. They're unlike the earlier Ender-3s where you had 3 ports to pick from to put the cable in. This only has 1, so you can't mess it up. Go ahead and hook that ribbon cable in place as shown. Okay, next up, we are going to connect the wires for the extruder motor, the X-axis motor, and the X-axis Z end stop switch. They are all labeled. And here's some close-up pics showing each one. This is the extruder motor. This is the X-axis motor. And this is the X-axis Z end stop switch on the bottom. Now, on the back of your printer, you're going to need to set it to the correct voltage for where you live. If you are here in the United States, you want this set to 115 volts. So it's going to come from the factory at 230. You're going to reach in there with an Allen wrench or a screwdriver and slide that red switch to the right, and then it will show 115. Make sure you have it set correctly before turning it on. Next, we're going to take a zip tie that comes with the printer and connect this cable just loosely to the back of the extruder. This will help keep it out of the way when printing. You're going to want to now plug in your Z-axis screw motor, and as this is a single plug right next to the motor, just push that in all the way. Okay, next up is belt tensioning. There is no good way for me to tell you how much to tension your belts. You don't want them too loose. Like I'm showing you here, I can just easily pull this over. I can flip it over. That belt is way too loose. You don't want to make it too tight where it stretches the belt, because the belt will fail. It'll get breaks in it and you'll have to replace it. This belt can barely shift over left or right. That's starting to get to the point where it's, that's probably about right, but that was starting to get too tight there. Line up with the front edge of the printer, and if you can push the belt not quite, but most of the way over that center raise portion of the extrusion, it's probably tensioned just about right. All right, next, what we're going to do is tighten down all four corners. We have to do this before calibrating the bed leveling system for the bed. What you're going to do is on all four corners, the bed leveling wheels, if you're looking from the top down, you're going to turn them counterclockwise. Turn them until you feel resistance. Don't force it beyond that. You're just wanting to compress the spring to about where you see right here. But turn it, should turn pretty easily, but once it wants to stop, don't force it any further. Then back it off 1/2 turn. Loosen it 1/2 turn from the point it wants to stop. And do this on all four corners. Next up, we're going to plug the machine in and turn it on, and your LCD screen should pop on and look like this. So, if it does, it's now time to get it leveled. So you're going to go to Prepare and go to Auto Home. And the machine will then go through and it will home all three axes. The bed will move back for the Y-axis. The print head assembly will move to the left for the X-axis, and then it will finally move down for the Z-axis. Okay, you're going to go to the Prepare menu and select Move Z and rotate that knob until it reads as 0. Then you're going to go to Prepare and Disable Stepper, and now we're going to manually level the bed once. You do this to get your bed close to being level with the print head, and then the auto leveler will take over and fine tune it. But you do need to manually level this machine one time after building it. So you're going to use a piece of paper, and what we're going to do is we're going to move the bed and the X-axis without pushing down on it. You just want to move it left to right and the bed front to back. Move it to the front forward right position, and use your paper under it while adjusting the knob underneath the corner of the bed to raise it up until that paper just begins to catch, okay? You want to feel it snag a little bit. And if you're looking from the top down, rotating that wheel clockwise will raise that corner up. Rotating it counterclockwise will lower it. And so we're going to do this 3 times in total. You're going to do the front right, then the front left, and then the rear 2 positions. Go back to do the front right, do them a second time, and then finish up by doing it a third. The reason you do this, every time you make an adjustment on a corner, the other points on the bed, if you're raising a corner up, the the 2 adjacent corners will act as a fulcrum and force the opposite corner down slightly. If you're dropping the corner on the opposite side will act as your fulcrum and slightly drop the 2 adjacent corners. So you're going to go through just go clockwise, adjust each of these corners 3 times in total. Go around once, a second time, and a third time, getting that paper to snag. You don't want it to be so tight you can't slide it under, but you do want to feel a little friction. Once you've done that, the bed is close enough to being level that the auto leveler will work. So what we're going to do now, before engaging the auto leveling process, is we have to set the Z offset. And what this does, and before we get into it, I want to show you a quick diagram so you have an understanding of what this is, because Z offset is something you will be adjusting from time to time throughout the life of the printer. The CR Touch auto leveling probe, shown here in green, will touch the bed and sense the bed at a position that is lower than your nozzle, okay? So when your printer homes and finds its 0 point for the Z-axis, the nozzle is a considerable distance away from the bed. This is called your Z offset, okay? The reason they do this is if the nozzle was at the same approximate height as the touch leveler, the nozzle would be impacting the bed when you auto level, and you don't want that. That would damage your bed and it would damage your nozzle. So you have an intentional gap here between the point where the CR Touch will actually engage the bed and where the bottom of your nozzle is. We have to tell the printer what this gap is, okay? And that is your Z offset number. It will always be a negative number, because what we're telling the printer is, okay, when you sense where the bed is with the auto leveling sensor, you need to go down this much more for the nozzle to be right at the bed level. And that's what we're going to determine here in this next step, is we're going to determine our Z offset number. Okay, so now what you're going to do is you are going to auto home the printer one more time. Then you're going to move Z down to 0. Not your Z offset number. This is just move Z. It'll be at 10. You're going to set it to 0. And then you're going to go in and adjust that Z offset number to a negative number while holding a piece of paper under the nozzle. Once that paper begins to snag, that is your Z offset number, okay? So once you find that Z offset number, you're going to go back to the main LCD, go to the bottom right, and then select auto leveling, and let it go through the whole leveling process, and it's going to probe various points all over the print bed. And then once you've got that done, you're going to go down on your control menu to store configuration and save all of those settings you just put in. Okay, next we're going to need to tweak a few things. To begin with, go into the control menu, go to motion, and then max speed. And you're going to go down to the very bottom and change max speed E to 50. It's normally set at 25. This is your extruder speed, and by upping it to 50 and using my custom Cura profiles, it's going to make retractions more effective and reduce stringing on your prints. So just change that to 50, and then go in to control and store configuration and select that to save that setting. Now, the Ender-3 V2 Neo, Creality did something that I just can't fathom why, but they took away the ability to turn off power loss resume in the, or power loss recovery in the LCD menu that the Ender-3 V2 has and a bunch of other Enders and CR10s have. They've always given you the option of turning this feature off, and I always recommend turning it off because one, it doesn't work that great. When you lose power, your heated bed loses its adhesion on the print, and the print slips loose, and then power loss recovery doesn't work. It also leaves a pretty good layer gap where it begins printing again. It's usually off by a layer, and so it just never looks right. It also, on a print, when you don't lose power, it produces surface artifacts, because what it does, how this works, is every single layer, after completing the layer, the printer will pause for a second, and write to the SD card what layer it just completed. And that's how the machine knows if it loses power and starts back on where it left off and where to begin. So what's going on here is every single layer you have this pause. One, that adds print time. Two, you get this little blob of filament on the print surface. So it mars your model, the outer surface, because you have this pause every single layer. And it's just not worth it. I mean, the number of times you lose power, they're so infrequent, and filament's not that expensive. It's not worth it to me to have prints that have lower quality just to have the option for power loss recovery, which may or may not work in the first place. So up till this point, Creality has always offered you the option of turning that feature off. They have taken that option away with the Neo series. So there's no option in the LCD menu to turn off power loss recovery. So if you want it off, you have to do it in the G code. And this is very, very simple to do. When you set up Cura, you select the Creality Ender-3 V2 as your base printer. This is a V2, even though it's a Neo, you still just select the V2. When you go into Cura, you can add this line of code very, very easily. You're going to go to the upper left menu where you have your printer selected and select your Ender-3 V2. And then you're going to click on Manage Printers. When that comes up, select your V2, click on Machine Settings. And when that comes up, on the left-hand side, you're going to see a column that says Start G-Code. The very first line will say Ender-3 Custom Start G-Code. The second line you see will be G92 E0 Reset Extruder. In between those two lines, we are going to insert a new line of code. And that line of code is going to be M413 space S0. Now, if you want, so you know what that line of code is later on, put a semicolon in and then just type whatever you want after it. The semicolon just tells the printer to ignore what comes after it. And we're just going to type a quick notation in there. I just typed power loss off. I know what that is. But you're going to make sure that's the second line of code. And then close that window out, and that will save that. And then now, anytime you have that Ender-3 V2 selected and slice a model, that line of code will be at the beginning of the sliced G code, and it will turn power loss recovery off on your Ender-3 V2 Neo. Okay, next up, we're going to try feeding some filament in. So go to Control, Temperature for the nozzle, and crank it up to 200. Next, you're going to want to get your spool of filament out. Make sure you do not let go of the end once you pull it out of the small hole on the rim of the spool. If this end goes loose and it snakes under another loop of filament on the roll is going to snag non-stop when you print, and you're just going to have failed prints left and right, and the spool will just become worthless then. Maintain control of this at all times. If you have to put this down, refeed it through that hole on the rim of the spool. That's what it's there for. When you cut this, cut it at an angle so it has kind of a point. Go around back, and you're going to gently bend that end of the spool that you're feeding in, wrap it around your thumb a little bit, and you want it to point downward when you feed it in. That helps it feed correctly and not snag when it engages the tube. Depress the lever on the extruder and manually feed that filament in through the heated system until it begins coming out the nozzle. Once it does that, you're all ready to print. Now, just FYI, if you have to take filament out of the machine, preheat it again to 200. Once it's at temperature, before you yank the filament out, manually feed in, depress the lever on the extruder and feed in about 2 inches worth of filament. What that's going to do is purge the melt chamber and make the filament easier to pull out. So feed 2 inches in and then yank it out. So do that anytime you need to change filament. My next video, I will cover the hot end maintenance on the Ender-3 V2 Neo. I will show you how to swap out the nozzles, the bowden tubes and the bowden tube coupler, and in the event of a clog, how to clean a clog out of the hot end. And that will be the very next video I do and post on this channel. If you would, please click the like and subscribe buttons. That helps me immensely with the YouTube algorithm, and I would greatly appreciate it. Thank you for watching.